Hello, this is Osama Samara, and in this video we will be studying a pressure vessel problem from ME 3190. In this problem, we are given a pressure cylinder with these design specs. The thickness is half an inch, the outer diameter is 6 inches, and the internal gauge pressure is 500 psi, and we're asked to find the maximum shear stress, tau max. First, let's start by doing some side calculations to find the inner radius. We can use this formula to find the inner radius, which is basically we're subtracting the thickness from the outer radius. d over 2 is the outer radius, so 6 over 2, this becomes 3. 3 minus half an inch gives you 2.5 inches, and that's your inner radius. Next, we're going to check if we're dealing with a thick wall or a thin wall pressure vessel. So, for a thin wall pressure vessel, the thickness must be less than or equal to 1/10 of the inner radius. If this holds, you have a thin wall pressure vessel. So for our case, the thickness is 0.5, which is larger than 1/10 of the inner radius, 2.5. This becomes 0.25. So we know we're dealing with a thick wall. Pressure vessel. Next, we're gonna calculate the tangential stress using this formula right here. And we're gonna look at different terms. So this term, PO times RO squared, becomes 0 because our external pressure is 0. PO right here is 0. And we're gonna plug in the values for PI, RI, and RO. And R right here, we're gonna plug in, of course, RI, because tau max is gonna appear at the inner radius, since we have an internal pressure with no external pressure. So if you plug in the values for PI, RI, and RO, you're gonna end up with PI is 500, RI is 2.5, RO is 3 inches, 500 for PI, and we're plugging in RI for R squared. And you end up with, if you punch in the numbers on your calculator, you're gonna end up with 2772.7 psi, and that's your tangential stress. Now let's move on to our radial stress, which is governed by this formula. Looks similar. Instead we have a plus instead of minus right here. So same thing, we're gonna look at the terms. Our external pressure is 0. And for R, same thing, we're gonna plug in RI. And if you plug in the numbers, you should end up with something similar, like this. 500 for PI, RI is 2.5, RO is 3, RO minus RI squared. So if you plug in the values on your calculator, you should end up with negative 500 psi for your radial stress. Now for our last step, we're gonna calculate tau max. And tau max is simply governed by this formula. Sigma t minus sigma r over 2. And this looks familiar. If you analyze Moore's circle, quick Moore's circle, sigma t, which is 2772.7 psi, is going to be right here. And sigma r, which is negative 500, is going to be here. And when you subtract sigma r from sigma t and divide it by 2, you get the radius of Moore's circle. Because remember, sigma t and sigma r are principal stresses. So if you plug in the values for sigma t and sigma r, you'll end up with a tau max of 1636.35 psi. And this concludes our problem. Thank you.